Morning, you guys. Coach Kubik here. Sorry I can't be here, but I'm going to do section 9.5. So we're going to skip section 9.4 for the time being. It's on word problems. I figured you'd rather me be around when we do that. So we're going right to 9.5. Today's the 30th of March, 2023. We are doing 9.5, the advanced elimination method. So we're going to go over some of the stuff from the elimination method, and then I'm going to show you a way that we can use it on some problems maybe we couldn't have last night. And I gave you a whopping 6 problems. So I know there's a little, they are a little work intensive. So just make sure that you do those 6. If you haven't answered one of these without work, that is a shadowy world. Whoever's doing this, there's a few times you might want to pause it for a few seconds just while they do it. Here's one. So here's a review problem. So if you did your homework last night and you understand it, you should be able to do this problem without any difficulty. So go ahead and pause right now, and I'm going to go right ahead and solve. All right, so the first thing here is the 2 and the 3 don't really work well together. So but the 5 and the 5 do line up. So the first thing I would do is I would subtract 2 from 1. So I would subtract this entire deal. Okay, and you might not have thought it, but you can subtract equations. This is what we talked about yesterday. All right, so just a few things here. I would line everything up. So here I have the C column. Here I have the D column. And then here I have the units column. Right? The equal signs are stacked one on top of each other. So it's just like I'm doing addition or subtraction where I'm lining up the tens place and the hundreds place and things like that. You've got to do that. So I am subtracting. So I think the easiest way to subtract is to add the opposite. So I'm going to flip the signs. Right after I flip them, circle them so you know that you have flipped them. Okay? So I have 3C plus 2C, which is 5C. I have 5D minus 5D. Those guys cancel. And I get nothing. Eliminated. And I have 20 minus 20, which is an unforeseen circumstance, which is 0. Okay? That's it. Now, all I have to do is solve for C. So I divide both sides by 5. And I get C equals 0. Now I need to solve for D. How do I solve for D? I plug into either equation. It doesn't really matter which one. So 3C plus 5D equals 20. So I'll use the top equation, equation 1. I just found that C is 0. So I have 3 times 0 plus 5D equals 20. 3 times 0 is 0 in every country on earth. 5D equals 20. Divide both sides by 5. And I get D equals 4. All right. So my answer is, C comma D, which in this case is 0 comma 4. So when C is 0, D is 4, so that is what I'm going for. My answer is an ordered pair. I put it in parentheses, connected by a comma. If I don't know which one goes first, we always put them in alphabetical order. Okay? Last thing I want to do is I want to check, and we've talked about this. I'm going to give you a little review question in a second. If I use equation 1 to solve, you should use equation 2, the other equation, to check. So I know that negative 2C plus 5D equals 20. So when I plug in, right, I get negative 2 times 0, that's this 0, plus 5 times 4, that's this 4, that should get 20. So 0 plus 20 is 20, so 20 is 20. So that's the correct answer, okay? No ifs, ands, or buts. So this is all review. I took 5 minutes doing review. So here's my review questions. Again, if you were doing this in the class, maybe pause it for a second. So here are my questions. All right, so number 1, how should you write an ordered pair? Number 2, which variable comes first in an ordered pair? Number 3, how can you check your solution to a simultaneous equation? Number 4, must every system of equations have a solution? And number 5, and this is going to come up when we start solving with advanced ones, which variable should we solve for first? Again, maybe pause it just for a minute while everyone gets a chance to answer those 5 questions. All right, so number 1, how should you write an ordered pair? Okay, so our answer is parentheses connected by a comma. That tells me that this is an ordered pair, that there are 2 answers that go together. Okay, so x comma y, a comma b, right? S comma t. All these things come up a lot. What variable comes first in an ordered pair? Right, the variables are in alphabetical order. Number 3, how can you check your solution to a simultaneous equation? And I would say if you can plug the solution into both equations, then it is correct. So in other words, there's an infinite number of ones that are solutions to the first equation. There's an infinite number of ones that are solutions to the second equation, but there's only one right solution that works for both. That's where they cross. All right, next, must every system of equations have a solution? The answer is no. And we saw this when we did graphing in section 5.1. So it is possible that when I graph it, I have something like this. So I graph the first line and it goes like that. And then I graph the second line and it goes like that. And these never actually intersect, right? Lines that never intersect are parallel, right? So the lines could be parallel. Okay? And then lastly, which variable should we solve for first? So yesterday when we did this, it was pretty obvious which one we should solve for because one of the variables lined up. So in the example that I just did, okay, the D's lined up. The C's did not line up, okay? So typically, one variable is easier, okay? But it doesn't really matter. Right? You choose. Today is your day, celebrated throughout the world. All right, so that brings us to the actual homework tonight. So I'll show you what we're going to look at. Here's example 1. So it says s plus 2t is negative 7. 3s plus 8 or minus 8t is going to be equal to 7. So you look at this and you're like, I just drank coffee. How am I supposed to solve this? Right? So if I add them right now, and that's not the correct thing to do, right? But I would get 4s minus 6t equals 0. Right? Well, nothing gets eliminated. The whole purpose of the elimination method is to eliminate. So nothing gets eliminated. So here they don't line up. So I'm going to have to use my big brain, and I'm going to say, I'm going to make them line up. Okay? And how would I do that? So I look at this, and I happen to see, well, this is positive 2t, and this is minus 8t. So maybe it would be nice if these two lined up, if that were an 8t. If I could make that an 8t, it would work. So what I want you to do is, just like I'm allowed to add or subtract these, I'm allowed to multiply and divide them too. So I can actually multiply that entire equation by 4. Okay? So technically you're multiplying both sides by 4, but I'm just going to multiply the entire equation by 4. So I have 4 times quantity s plus 2t equals 4 times negative 7. So after I do that, I get 4s, right? So I'm distributing that 4, plus 4 times 2, 8t equals negative 28. Okay? So then what do I do now? Right? Well, now the other equation is 3s minus 8t equals 7. This is what you have to understand. They did not line up. So tonight on the homework, right, no variables will line up. We will make them line up. Right? We will make them line up. So now I think this is an easy question, right? So I'm going to add them, right? 4s, this should be an s. 4s plus 3s is 7s. 8t minus 8t. Eliminated. Eliminated. And then negative 28 plus 7 is negative 21. So I have 7s equals negative 21. Divide both sides by 7. And I get s equals negative 3. So again, here hopefully you're kind of quizzing yourself or asking yourself some questions. How am I going to solve for the other one? So here, okay, I know that s plus 2t is equal to negative 7. So I plug this in, right? Plug and chug. So I get negative 3 plus 2t equals negative 7. I add 3 to both sides. 2t equals negative 4. Divide both sides by 2, t equals negative 2. All right, so how do I write it? So remember, parentheses, connected by a comma, alphabetical order. So my answer is going to be negative 3, comma, negative 2. There's my parentheses. Now, to check, all right, the top one, s plus 2t, is equal to negative 7. I use that to solve. So you use the other equation to check, right? Use the other equation to check. We went, just to go back over what we did on the previous page, I know the answer is going to work for both of these. Since I use this one to solve, I know it works for the top one. I just got to make sure it works on the bottom one. That's why I use the other one to check. So I have 3 times negative 3 minus 8 times negative 2 equals 7. 3 times negative 3 is negative 9. A negative times a negative is a positive, so I get negative 9 plus 16 equals 7, which means that 7 equals 7, which is correct. So now that I know this is correct, I'd probably go back and box it, ring it, whatever you want. All right, so that's what we're looking at tonight. Just to review. Nothing is going to line up when I first get the problem. I want you to know that's okay. We're going to make them line up, right? And how am I going to make them line up? I can multiply or divide them just like I can add or subtract them. So I can do my formulas, do my properties on these things too. All right, example 2. And again, whoever's running this, you might want to pause it for 2 minutes after we're done just to make sure that the kids get a chance. So here on the top, I have 2x plus 3y equals 12. I'll call that equation 1 if I talk about it later. And then on the bottom, I have 3x plus 2y equals 13. All right, so again, I hope you pause. This one's actually hard, and I'll tell you why. Because there's nothing I can do to 2 to make it line up to 3. I guess I can multiply by 1.5, which I'm going to assume that none of you ever want to do. Same thing, there's nothing I can do to 3 to make it into 2. I can maybe multiply by negative 2/3. So there's nothing I can multiply the top by to make it equal to the bottom, and there's nothing I can make the bottom by to make it equal to the top. So what I'm going to do here is I have to multiply both. So I'm going to multiply equation 1 by 3. So I have 3 times 2x plus 3y equals 12. And that's going to give me 6x plus 9y equals 36. Let me just double check that. 3 times 2, 6. 3 times 3 is 9. 3 times 12 is 36. So now, right, there is something I can multiply this by that's going to make these line up. And I'm going to multiply the bottom one by negative 2. Now, where did the negative 2 come from? Okay, well, I know that the LCM of 2 and 3 is 6. Okay, and I also, if I wanted to, I could have multiplied by 2. But I'm going to do negative 2 times 3x plus 2y equals 13. So I get negative 6x minus 4y equals minus 26. So I could have multiplied by 2 and then I would have had to subtract. So what I did instead is I just multiplied by negative 2 and then I could just add. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. Negative 2 times 13 is 26. So this is the magic of this method. When I go to solve this, right, the first time nothing lined up. I'm like, this is impossible, right? You're thinking maybe I should graph it or maybe I should substitute. But I can still use elimination, right? So now I just add these two equations. 6x minus 6x, eliminated, 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 right? 9y minus 4y is 5y, and 36 plus negative 26 is positive 10. Divide both sides by 5, and I get y equals 2. So I'm literally halfway done. I think I've done most of the hard work. So now I want to check. Now you might be tempted to check using one of the new equations, right? But I will tell you, you should check using the original equations. So check using the original equations. And the reason is if you made a mistake finding these equations, you might not find it if you use the mistaken one to find it. Okay? So we'll say check using original equations. Okay? So when I go to solve this, 2 times x plus 3 times 2 equals 12. 2x plus 6 equals 12. Subtract 6 from both sides. 2x equals 6. Divide both sides by 2. X equals 3. So again, this one's pretty easy. It's going to go xy connected by a comma, right, surrounded by parentheses. So I should write my answer as 3, 2. Before I box it, let's see if I have the right answer. I'm going to go to this thing. It's this boring black color. All right. So I used the top one. to find x, so I'm going to use the bottom one to check. Don't use the same one for both. Okay? So I'm going to plug in, so I say that when x is 3, y is 2. So 9 plus 4 equals 13, which is correct. There's the box. All right, you guys, I'm getting a little long, so I'm going to do one more. I just have one more small note. So I happen to see that the 2 and 3 lined up perfectly, and that's where I eliminated the x's. If I wanted to, I could have eliminated the y's. To eliminate the y's here, I would just do negative 2 on top, or 2 on top and negative 3 on the bottom, and that would have made the y's eliminate. So you have a lot of ones. Last one, and this one, try and get it on your own. It's not going to get much harder. This one is about as hard as they get. So I have a plus 5b equals 8, and 3a plus 7b equals 0. So why don't you guys try it on your own? Proctor, please pause it for a minute or two. And again, I'll go right into the answer. So I'm going to actually solve this a little differently. I'm going to use elimination twice. So the first time I'm going to do it, I'm going to eliminate the a. And the second time I do it, I'm going to eliminate the b. All right, so I go to do this, and I say a plus 5b equals 8, and 3a plus 7b equals 0. So I notice that for these two, if I want to eliminate the a, I would use negative 3 there. So I get negative 3a minus 15b equals negative 24. Again, all I did was distribute this, right? Negative 3 all the way across. So I have negative 3a minus 15b equals negative 24. And then I have 3a plus 7b equals 0. Just add them. Negative 3a plus 7a, eliminated. And then negative 15b plus 7b is negative 8b equals negative 24. Divide both sides by negative 8, and I get b equals 3. The second time, I'm going to eliminate b. Okay? The second time, I'm going to eliminate b. Now, again, I'm just doing this so you can see it as like a thought experiment to show you that you could eliminate either one. It doesn't matter. Normally, what you would do is take this b equals 3, substitute it into this, solve for a, write your answers in ordered pair, plug it in here to check, circle your answers if it's correct. But I could also do it this way, so I want you to see. I have some play in how I'm solving this. So here, I have a plus 5b equals 8, and 3a plus 7b equals 0. So I just happen to notice that the 5 and the 7, right, I can get them to line up if, right, I multiply the top by 7 and the bottom of negative 5. How do I know that? Because the LCM of 7 and 5 is 35. The least common multiple is 35. So I multiply everything here by 7. I get 7a plus 35, that's right, you heard it, 35b equals 56. Here I distribute, I get negative 15a minus 35, that's right, 35b is equal to 0. Okay? If you're wondering where I got these numbers, I'm just distributing this across the whole thing. Okay? So that gives me 2 new equations. But look at that. Oh, wait for it. Wait for it. I'm going to add these. So I get negative 8a, 35b minus 35. Eliminated. Those cancel, and I get equals 56. Divide both sides by negative 8. I get a equals negative 7. So my answer, ordered pair, a comma b. I just figured out A is -7, and I already figured out that B is 3. So my answer is -7, 3. If this is a test and you finish early, you could go back and check. But that is tonight's homework, the advanced elimination method. Do your best. I will be back in school tomorrow. Peace!